So, the topic for today, guys, is about rectilinear motion with variable acceleration. So, variable acceleration can occur when the average acceleration of an object changes at different points along its path. So, this can means that acceleration changes in magnitude, direction, or both. So, variable acceleration can also be defined as when the velocity of an object changes different amounts to equal in time interval, or even the time interval is very small. So, variable acceleration can also known as non-uniform acceleration. It can occur when a force is stopped, or a force is suddenly turned on, or when a direction of an object is suddenly changed. So we can say that variable acceleration can be found in any parts of kinematic problem. So to solve variable acceleration, we need to derive or integrate functions of time. In your motion of variable acceleration, we can get this equation. So the first equation is the velocity is equal to the first derivative of distance over the time t. Second equation is the acceleration is equal to derivative of the velocity over time t. Third equation is we can get this equation by dividing this and cross multiply. So we can get this, the equation of the function of distance. So how do we get the velocity or the acceleration when we don't know the principle? So let's also know the principle. The first principle is the distance. So the distance, also known as the s, we have a unit of meters, kilometers, in foot, and etc. So the second is the velocity, or the v. Can get it by unit of meters per second, kilometers per hour, or feet per second, etc. And the last is the acceleration. Or the A. We can get it by the unit of meters per second squared, feet per second squared, etc. So as I said before, we can get the distance, velocity, and acceleration by deriving the function of a time, or integrating the function of time. So question, what if we start in the equation of acceleration? Is it good? Yes. We can also get these two by integrating the function, the equation of acceleration, and we can get the velocity. So I have a trick for you guys. So we can say that d is distance, and v is velocity, and a for acceleration. So if the given of the equation is the distance, we can get the velocity by deriving the function of time. So derive and derive, so we can get the acceleration. And we can get it by backwards, so we can integrate, so we can get the velocity if the given is on the acceleration equation with that time function. So to apply this concept, to apply this equation, we have to answer the examples. Let's start. So we'll solve a problem. So problem 1. Start a car, moves in a straight line such that for a short time its velocity is defined by v is equal to 3t squared plus 2t meters per second, where t is in seconds. A determine the distance traveled when time t is equal to 3 seconds. B is determine the acceleration when time t is equal to 3 seconds. So start by reading the problem. So a car moves in a straight line such that for a short time its velocity is defined by v is equals to 3t squared plus 2t meters per second, where t is in seconds. So A, determine the distance traveled when time t is equals to 3 seconds. So as I said before, you can get the distance by this equation. So we all have to do is know this concept. These for distance, velocity, and acceleration. And we all know that the function is from velocity. It's from here. So we're finding the distance traveled. So it's the distance. So to get this distance, we need to integrate the velocity so we can get the distance. And to get the acceleration, we need to derive the function to get the acceleration. So start in A. V is equal to 3t squared plus 2t. So we need to derive, we need to integrate the function to get the distance. So you change this into ds over dt is equal to 3t squared plus 2t. Cross multiply, squared plus 2t dt, and derive integrate from 0 to time to 3 seconds. So we need to integrate this t cubed over 3 plus 2t squared over 2. Cancel. So t is 3 seconds. So 3 cubed plus 3 squared is equal to 36. So the answer is 36 meters. So that's how you can get the distance when the given is the velocity function. And B, we need to get the acceleration. Start in the velocity function, 3t squared plus 2t. So we can get the acceleration by deriving the velocity function. So let's derive that by ds over dt, cross multiply t squared is 2t dt. So let's derive it by t squared plus 2, and at time is equals to 3 seconds. So ds over dt is equals to dv over dt is equal to 6 times 3 plus 2. So dv over dt, or a, is equal to 2. So it's equal to 20 meters per second squared. A is equal to 20 meters per second squared. That's our final answer by this problem. So let's move on to more complicated problem, by problem 2. Second big problem, the position of a particle along a straight line path is defined by S is equal to t cubed minus 6t squared minus 15t plus 7 in feet. where t is in seconds. So a is the velocity at 10 seconds. B is the acceleration at t 10 seconds. So the given here is the distance. So the position of a particle along a straight line path is defined by S is equal to t cubed minus 6t squared minus 15t plus 7 feet, where t is in seconds. So let's find the velocity and the acceleration, where we know that we can get the velocity and acceleration by deriving it. The first derivative we can get is we can get the velocity, and the second derivative is we can get the acceleration. So start in s t cubed minus 6 t squared 15t plus 7, and we're gonna derive it to dt. So three t squared minus 12 t minus 15, and t is equals to 10 seconds. So 10 seconds. So 3 times squared minus 12, 10 minus 15. So we can get our velocity dv over dt is equal to 12, 10 plus or minus 15. So we can get 165 meters feet per second. That's our velocity. Correction, guys. And to get our acceleration, we need this derived function, and we will derive this function to get the second derivative. So v is equal to 3t squared minus 12t minus 15. And we're gonna derive it by ds dt plus multiply. So dv over dt is equal to 60 minus 12 at t is equal to 10 seconds. So acceleration is equal to 48. So that's how to get the acceleration and the velocity. you also remember the concept of how to derive or when to integrate. It's very important to know when to derive or when to integrate if we both know this concept. So let's move on to another example. Let's move on into a much more complex problem than before. So, go to problem number 3. Determine the velocity and distance of a body after 2 seconds if the motion is defined by the relation A is equals to 2t, A being in feet squared and t in seconds. And if it is known that S is equal to 4 feet and V is equals to 2 feet when T is equal to 1 second. So, the question is, find the velocity and distance of a body after 2 seconds. So, let's start by finding the velocity. So, to find the velocity, we need the equation of the velocity, which is dv is equal to A is equals to dv over dt. Cross multiply A dt is equals to dv. And we need to integrate it and we have the limit of the velocity and the acceleration. The time limit and the velocity limit. So velocity is, the initial velocity is 2, the final velocity is v. So the initial time is 1, the final time is t. So we all know how to integrate, so let's integrate it. So the integral of dv is v. So it's a limit of v and 2, and the integral of a dt is a. Also need to substitute this acceleration by this value can get. So 2t dt, 1 and t. We can integrate it into 2t squared over 2. Cancel. So it has a limit of t and 1. 2 and v. So substitute the upper limit and the lower limit. So we can get, substitute the upper limit is the same v, and substitute the lower limit minus, substitute it into 2. So the t, substitute the upper limit, it's the same, t squared, and substitute the lower limit, minus 1. So you can get the velocity, by transpose the negative 2. So v is equal to t squared minus 1 plus 2. So v is equal to t squared plus 1. So we can get the velocity by substituting the time of 2 seconds. So v is equal to 2 squared plus 1. V is equal to 4 plus 1 plus 5 feet per second. So let's get the distance by getting the distance equation. So ds is equal to v dt. The equation of velocity. So we can integrate it and we can get the distance. So v is equal to ds over dt. Cross multiply, v dt is equal to ds. And we can integrate it, or we can substitute it by this equation. So t squared plus 1 dt is equal to ds, and we need to integrate it with the limit of distance 4 and s, and the limit of this is the time 1 and t, and we can integrate it into s. Substitute the upper limit and the lower limit is minus 4, and we can get this by substituting, integrate and substitute the upper limit and lower limit. So we need to integrate it to t cubed over 3 plus t. Substitute the upper limit and the lower limit. So we can get, substitute the upper limit, the same, 3t over 3 plus substitute the upper limit t, minus substitute the lower limit, 1 cubed over 3 minus plus 1. So get this equation equals s minus 4. We can transpose this negative 4 to this and we can get the distance. So s, let's write it in here, s is equal to t cubed over 3 plus t 8 over 3, and we have a distance equation, and we need to substitute the time into 2 seconds. So distance is equal to 2 cubed over 3 plus 2 plus 8 over 3. So we can get our distance. cube 7.33. So our distance is 7.33 feet. So that's how to get our velocity and distance. So we also have to take note that in order for us to get the velocity and the acceleration, we also have to know how to derive and to integrate. And we also have to know when to derive and when to integrate the function. The functions that are given are also very important for us to know where it is used and how to use it in order for us to get the value